Okay, we're going to take a look at making inferences by observing fossils. We're going to go through and kind of talk a little bit about your observations and just a little bit about what they mean to prepare you for our next assessment, which is coming up. Let's take a look at station number 1. These were the fossils that I brought back from Montana. The first was the Triceratops toe bone. So you had to make a decision whether the Triceratops was a very large organism or about the same size as a human. When we look at the photos here, let's go to our Triceratops toe bone here. All right. Think about this. Like this would have been one bone in my finger. So just like my toes, I have 3 bones in my fingers and 3 bones in my toe. This would have just been one small bone from a Triceratops in their toe. So we can see that the Triceratops was actually much, much larger than a human being was, right? So we can infer, obviously, that dinosaurs were really, really big. All right, let's take a look at number 2. These were the teeth from our theropods and our Triceratops. And the correct response was to circle that theropods were carnivores and Triceratops was an herbivore. So let's take a look at the images for that. Let's start with our theropod here. Okay, so here's our theropod tooth, and you can see that it's kind of curved, and if you look closely, you can actually see that it's serrated like a steak knife. It's got little ridges. And when we compare that to the modern day skulls, it most closely resembles one of the canines from our coyote here, right? So these teeth are both used by predators to kill their prey. So we can use clues from past organisms like, for current organisms like the coyote to tell us a little bit about what maybe even theropods ate. And we can infer that theropods were meat eaters based on the shape of their teeth. The opposite was true of our Triceratops. Okay, when you look closely at the Triceratops tooth, it was kind of flat and rounded at one end. It was more similar to the tooth of our deer, right, an herbivore. So scientists, by looking at modern day organisms, can conclude that Triceratops was most likely an herbivore. All right, let's see what's next here. So the gar scales. You had to choose if the gars looked about the same as they do today or if they look different. And when we look at the scales from the gar, one thing we notice is that these gar scales are pretty much identical outside of color. And remember, one of them is a fossil, so this one's made of rock and this one's made of bone. Okay, so that describes, or that's why their colors are different. But they're pretty much the same shape, same size. In fact, this is what a gar looks like today, right? So this is an alligator gar. They're kind of big. You can see here's one standing next to a man. They can get really, really big. A lot of people call these living fossils. They've just been on Earth for so long that people call them living fossils. And they've got these big, ugly, sharp teeth. Ugh. All right, and finally the turtle shells. The environment was probably aquatic and not a desert when this organism was alive, right? So when we take a look at the ancient turtle shells, just their presence tells us that Montana, the Badlands, which is now really, really dry and almost like a desert, back then had to be aquatic. There has to be water for turtles to survive. And their shells of these turtles indicate that the landscape in the past was aquatic. Okay, let's take a look at station number 2. So in station number 2, you had to make some observations. Let's flip over here to those observations. Okay, let's start with your drawings. All right, so double check. You should have a drawing for number 1, A, B, C, D, E, and F. If not, pause this and draw in the correct drawing there. And then you should have just learned a little bit about each of the fossils by finding out what their name was, what their niche was, and their habitat, and how old they were. Okay, so go through. I'm going to make this a little smaller. Go through and double check your work for each of those. Pause it if you need to. Okay, there's A, B, and C. And here is D, E, and F. Pause it if you need to. All right. Let's go ahead and we can close that out. We're done with that. let's take a look at station number 3. So station number 3, you had to estimate the size of the dinosaur skull by looking at the tooth of the dinosaur. All right, so let's check our math and our measurements here first. Okay, when I did my measurements, I measured the length of the tooth as 16 centimeters. When I measured the length of the skull on the piece of paper, it was 24.4. And then when I measured the length of the tooth on the sketch, it was 2.3. Okay, so don't change your measurements, just kind of check to see that you're somewhat close to those. All right, and here's the math that we use to solve for how big the skull was. All right, I'm going to start with the length of the actual skull. That's what we're trying to figure out. That becomes x in our equation here. We knew that the length of the tooth cast was 16 centimeters. The length of the skull on the sketch was 24.4, and the length of the tooth on the sketch was 2.3. Okay, so what I have to do is I have to cross multiply. So I'm going to say x times 2.3, so 2.3 times x, equals 16 times 24.4. All right, and when I do that math, I get 23.3x equals, oh, I'm sorry, before we do anything else, what I want to do is I want to eliminate and get rid of the 2.3 on this side, so we can have x all by itself. And to do that, I'm going to divide both sides by 2.3, so I can cancel them. So I'm going to divide my left side by 2.3 and my right side by 2.3. And that leaves me with x equals 390.4 divided by 2.3. And according to my math, the skull would have been an estimated 169.7 centimeters. So check your answer, see if you're close there. Okay, and let's go back up and look at these questions. Use a reference such as a poster, textbook, or model to identify what kind of dinosaur this skull represents, and then using the same type of mathematical estimation as you used in number 4, estimate how long this dinosaur was, how much did it weigh. Well, I didn't go through and estimate using the math. I looked it up, but this is from a T-Rex, and it would have been about 40 feet long, and it would have weighed about 5 to 7 tons. Okay, do we think this was an herbivore or carnivore? Well, based on our previous station, we know that this was a carnivore because it had sharp, killing, or canine-like teeth. And finally, name this famous animal. Did the name have a meaning? Okay, so we know that T-Rex, I looked up, means tyrant lizard king. Tyrannosaurus rex means tyrant lizard king, which, what a cool name. Okay, let's take a look at station number 4. This was the Triceratops frill, and we have a photo of that here. All right, that looks like this. Oh, come on, quality, let's get better. All right, as part of the frill, I asked you guys to take a quick look. Let's see if I can go back out and come back in. Maybe it'll be a little bit better quality. There it goes, okay. To take a look at these black structures running through throughout the frill. And what these are actually veins. The Triceratops was cold-blooded, and the Dr. Burnham said that the Triceratops may have pointed its frill at the sun in order to warm its blood up. So we can actually even infer a behavior based on a fossil, right? Because we see all these veins like this that have been fossilized into the frill. We know that it's cold-blooded, and we think that maybe the Triceratops would actually kind of position its head to help warm up in the wintertime, or even when it's just cold. All right, let's go on to station number 5. Station number 5 was the footprints. Okay, so let's take a look at the footprints. We have 2 sets, A and B. Let's take a look at set A. That was this set, okay? And let's answer some questions about them. Why are the footprints 2 different sizes? Well, let's get to my notes here. All right, so one is a back foot, and we think the other would have been, we could infer as a front foot. So this would have been the back foot of the organism, and this would have been the front foot of the organism. Did this animal have a perfectly flat foot or pads like a dog? All right, so it would have had pads. You can actually see the spaces in between the pads here. So it didn't have a flat foot, it actually had pads. Did this animal have long claws or dull toenails? And we would have seen that it has dull toenails, right? These weren't super long. This creature lived during the Jurassic time. Try naming an animal, okay? I'm not sure. Really don't know what this guy is here. And if you do know, let me know. That'd be great. It says these footprints were found with 3 other parallel sets of tracks going in the same direction. What can you hypothesize about dinosaurs that made the tracks? There wasn't a space to put this answer in here, but maybe it was chasing some prey, or maybe it was running away from an animal. Maybe it was following another group of animals. Okay, we can make all kinds of inferences from that. Okay, let's take a look at our second photograph here. Let's see here. Over here, I've got to go this way. All right, so we have a second set of dinosaur prints here. Did this animal have dull toenails or sharp claws? Well, we can see that it had sharp claws. These are much pointier. How could the sharp foot claws be useful? Well, they might have been used to slash or grab their prey. It says the next question is, these footprints were found in a limestone layer that also had freshwater clams in it. Explain how this could have happened. And this dinosaur might have been walking near a lake or a river when he left these footprints. That's the only way to explain why there was clams nearby. And try identifying it by name. Once again, I don't know what this is, but it's definitely a theropod. Theropods were meat-eating dinosaurs that walked on 2 legs, so this would have been a theropod. Okay. Number 3, now compare the 2 sets of footprints. Which set is probably 4-legged, heavier, and slower? Well, in that case, that is definitely set A here, which is probably faster. That would be set B, right? It's easier to run on 2 legs. And this would have been a much probably larger dinosaur. Which is probably the predator, and that would have been set B as well. All right, and for each set of footprints, name several modern-day animals that would leave similar footprints. Okay, so for set A, that could be dogs, lions, elephants, hippos, and set B could be chickens, birds, or eagles might have similar footprints to those. All right, let's go on and let's finish. Let's take a look at the last station here. Station number 6, you guys had to describe the different types of fossils. Okay, so that was your first set here. I'm sorry, station 6, there we go. All right, so specimen number 1 was, you can read over the different descriptions of the specimens here, see if they match up with yours, okay? And then we had to match up which fossil matched the habitat. So we can learn a lot about a habitat by looking at the fossils that were left behind in them as well. So letter A, an ocean floor where the fine mud and sediments are settling to the bottom. That was number 3. A beach made of mostly broken shell fragments. That was number 5. A freshwater lake with small fish was number 4. A swamp with decaying ferns was number 1. And a shallow ocean with a coral reef was number 2. Okay, and then here's some places on Earth that kind of match those habitats. These are where fossils are being formed right now, so you can check that in your notebook as well.